Today we have two very interesting speakers with us. First up, we have Evan Yeo. Evan Yeo is renowned as the creator of Vue.js, a popular open source JavaScript framework, and Vite, a modern web development build tool. He's also the founder of Vite, which focuses on building the next generation of toolchains for JavaScript and TypeScript. Let's put our hands together to welcome Evan Yeo.
Hello everyone. Okay, so first thing first, it's called Vite. Yeah, I know a lot of people like read it as Vite, but so the story here is Vite is actually the French word for quick. So when we created the tool, we were like, what word can mean quick? Starts with V and is available on npm, and here it is. Okay. So it's about me. Long time ago, worked a bit at Google. Then I worked at a startup called Meteor, but that was like more than 10 years ago. I have been doing independent open source since 2016. In fact, I was at Friday Hacks, I think last year. Was it last year? More than a year ago, talking about how I got into open source, how I got to do open source full time, and all that. I think the recording is still on YouTube, so if you're interested, you can go check it out. So during that time, I worked full time on Vue, on Vite, and other open source projects. And I moved to Singapore in 2021. Before that, I was in New Jersey on U.S. East Coast for over a decade. And I founded the company Voice Zero in 2023. So we are still quite new, but so this talk is mostly focused on, Vite, the build tool, JavaScript, like how we got here, why do we need to build this, what are we building now, what are we planning to build next, and hopefully inspire some of you to contribute and participate in some of these stuff. So first of all, what is Vite? How many of you have either heard of it or actually used it? Raise your hand. Great, great, a lot of you. Okay, so Vite is a web app build tool. So when you build web apps, right? When we first got into web development, like for myself, when I first got into web development more than 10 years ago, everyone started with just like, here's HTML, here's CSS, then you sprinkle a little bit of JavaScript on top of it, and here's the web page, right? But nowadays, we think of the web as an application delivery platform. It's not just for web pages anymore. We actually build pretty complex apps on the web, right? So a lot of things you use daily, like Gmail or say Slack or Discord or Figma even, they're all web apps, right? A lot of very complex apps, and they're built with web technologies. And to build serious apps, you need proper engineering. And JavaScript was born without any of that. When it was created, its author, Brendan Eich, he created language in literally 10 days. He designed it when he was asked by, I think by Sun Systems, say like, we need a lightweight scripting language. It has to look like Java. So he was like, okay, JavaScript it is, and he did it in 10 days, and there were tons of interesting design quirks in JavaScript that still exists today. But my point is, it started as a language that was not meant for serious engineering at all. Over time, however, it became the only language that's actually runnable in browsers, right? And browsers became more and more powerful. So now we're building all these crazy apps in the browser. And JavaScript kind of had to evolve to live up to this sort of challenges that were thrown at it. So the language itself evolved over time. There were multiple editions of the language. The official standard for JavaScript is in fact called ECMAScript, ECMA, which is the standards body that oversees the specification of the language. So it's also short for ES, which actually is the official name for JavaScript. Some anecdote, JavaScript, the name is actually still a trademark owned by Oracle. And there's some dispute going on in trying to free it. But anyway, so the whole situation now is, okay, JavaScript language is there. We're trying to build very complex stuff with it. So we need better tools to support that demand. the language itself did not come up with any of the tools that's needed to do this kind of level development. If you are getting into a newer language, they say Rust, right? How many of you have written Rust or at least tried to learn it? Okay. You get into it, and the first thing you know is like, oh, we have Cargo. Cargo does everything for you. It does like linked, build, test, format, all the things you'd want from a proper language. There are these things. JavaScript has none of that. So over time, we basically had to build these things from scratch. And there's no central guidance to how to build these things. So the result is, different teams, different people at different times just run into the problem, and they're like, no solution exists for this. I guess I'm going to build it for myself. And because different people build these things, they were not designed to work together. So when you first got into web development, you're probably faced with a lot of, choice paralysis. It's like, what do I even use for this stuff? Like, why are there so many options, right? Okay, so long story short, Vite is a tool that over time, as I'm building Vue.js and maintaining our own tool chain, I got fed up with the situation. I was like, we need something that's simpler to help people get started with building web apps a bit faster, a bit easier, right? Also, the performance needs to be better. So Vite is fundamentally a web build tool. It has a dev server, has a bundler for production builds. It's fast, simple, and flexible. It has, in fact, over the past few years, become a shared infrastructure layer for a lot of different web frameworks. So we have formed a cross-framework ecosystem around Vite. But why do web apps need build tools? So this is essentially what I was talking about, right? So if you are more experienced in web dev, you probably know like you'd use TypeScript, you'd use JSX. You want hot module replacement, which means instead of recompiling your app, the whole app, every time you save, you want the component you're working on to just update instantly without resetting the state of your application. If you've never done modern web development, say if you've done like native development, have you had the times like you have to wait for the whole thing to recompile, right? Like there's the meme where like you're drinking coffee because you're waiting for the whole thing to compile, right? In modern web dev, it's less of a thing because we're so used to just like hit save, everything just updates instantly because of hot module replacement. And there's also better production performance concerns because we are delivering apps over the network. So unlike, say, iOS apps where you first download, then you open the app where everything is already local, right? Web apps are almost always on demand. So you visit a URL, then it actually starts fetching everything over the network, right? So if your app bundle is really, really large or it's not properly optimized, it takes more time to send the bytes over the network. So if you're on a bad spotty network on your phone, like you're in the tunnel and you're trying to open an app, it probably takes forever, right? You can optimize it to make it load faster. So that's a unique concern for web apps. Okay, so that's why we need build tools. And the brief history of Vite is it started in 2020 as a prototype. It was initially designed as a only for Vue. I was just trying to say like the build tooling that we used for Vue was called Vue CLI. It was based on a pref-gen tool called Webpack. And one day I was starting up a new reproduction, and it took so long to install and start the whole thing. I was like, I've had enough of this. I want something that's easier, simpler. So I started hacking on Vite, initially only for Vue. I got a prototype working, and I realized it is actually so promising that I decided to turn it into a real project. And halfway through, I'm like, this actually is not specifically only for Vue, right? It can apply to any framework. So we basically abstracted all the parts that's framework agnostic and turned Vite 2.0 into something that can support React, well, it doesn't support Angular, but most of the other frameworks it can support. In fact, today there is a Vite-based Angular framework, meta framework. It's not the official implementation, but it's also possible. Angular team has reached out to us, so there's potential collaboration happening down the road. 2022, we see the trend of meta frameworks. If you are into the JavaScript ecosystem, you know there are tons of base frameworks, so React, Vue, Angular, Svelte, and then on top of these base frameworks, there are what we call meta frameworks, essentially more full stack JavaScript, server-side rendering, a lot of fancy stuff. But the common trend here is most of these new fancy meta frameworks are being built on top of Vite. And started in 2022, we see Nuxt 3, SvelteKit, Astro, Solid Start. In 2023, some of the previous existing React meta frameworks also decided to migrate from Webpack over to Vite, like Redwood Remix, which is now known as React Router 7. And 2024, we see like 10 Stack Start, One, Ember, so old frameworks, new frameworks, all convergent on top of Vite. In fact, as of today, Next.js is the only meta framework that's not using Vite. So we've been talking with them, like we're like, hey, if you want to move to Vite, we're totally open, but they're like, oh, we invested so much into TurboPack and it's so risky to migrate. So, maybe in the future, but not now. So 2025, if you use React, you probably know that Create React App, which was the previous official way of starting a new React application, just got deprecated. And there's actually a lot of sort of drama around like people complaining why the React docs they just not directly recommend Vite as a replacement for Create React App. Well, it's a long story, but short story is React team wants to push for a more framework-oriented approach because they want people to use React with React Server components, which is the new thing they're trying to push. And when you use Vite, you usually start with single-page applications. So it's like pure client-side. You don't need a Node.js server on the back end. It's simpler, in my opinion. It's the more straightforward way for people to start learning, getting into React, getting into web development in general. But they want to push frameworks, so they kind of indirectly mention Vite by saying, hey, you can use React Router, which is now a framework, but React Router now actually ships as a Vite plugin. So you can use Vite to do that. So we're now at like 25 million weekly downloads, which is quite a lot, but npm downloads usually contains a lot of duplicates, like people just downloaded the thing over and over again on CI. But a relative number is we actually overtook Next.js 2 years ago, and we're like pulling way ahead of it compared to overall usage. So in state of JS 2024, essentially Vite and Vitess swept most of the award categories in terms of adoption growth, retention, interest. So retention is defined as people who've used it and want to continue using it. And highest interest is people who haven't used it but want to use it. And we have a vast ecosystem. So meta frameworks that's built on top of Vite, tools that consider Vite a first-class citizen, like Storybook, NX, Tauri, and tools that leverage Vite to do certain things. Like if you use Playwright, it has a component testing feature, which actually use Vite to bundle your components. And Laravel ships with Vite by default. There are first-class integrations for if you want to use it in Rails. Rails 8 went the whole like no build tool approach, but some community members still want to use Vite with it. So there are like gems that allow you to do that. So we also have some big names using Vite through open source. One of the examples you probably don't know is the ChatGPT web client is now using Remix, which is Vite-based. Shopify, Reddit, they all moved their internal Webpack application over to Vite. So if you are browsing Reddit, it's actually built by Vite. Linear is also built on top of Vite. So there are also various usages inside these big companies. So all of this is just to make the point that Vite has become a shared infrastructure layer for the next generation of web applications, right? So kind of bragging a lot, right? But Vite is not perfect, which is why the work is not done yet. So what are we working on now? Before we talk about that, I want to talk about the problems. So inside Vite, when I created Vite, it was done overnight as a prototype. So there are some hacky decisions in there. For example, we use a bunch of other dependencies to handle some of the harder things. Like we use esbuild, which is written in Go, for what we call dependency pre-bundling, transforms, minification. We use rollup, which is a bundler written in JavaScript. And for React users, they often opt in to use SWC, which is a compiler toolchain written in Rust. So a typical React application building on top of Vite today actually uses all three at the same time. And because they all kind of do different things, there are overlaps, they do some similar things, but why do we have to use them? Because none of them actually does all the things. So it's like, we have to use them all at once. So the problem with this is, so esbuild does some things really nicely, but we don't really want to use it to bundle production apps because it has very limited chunking control, which is kind of critical if you're shipping production level applications. Limited flexibility in its plugin ecosystem, and it does not support hot module replacement. So rollup is written in JavaScript. So like esbuild can be, say, 10 to 20 times faster than rollup when you're building the whole thing for production. SWC is written in Rust. It's quite fast, but for our use cases, we only really need a tiny part of it. But the whole thing is like 38 megabytes of binary every download. So we're like, we can't really include this by default. And if it has a production grade bundler, we'd be happy to just use it wholesale, but it doesn't have one. It's not really complete. So the unfortunate state of things means we have to actually use all three at the same time. So the result is they have very subtle inconsistencies. Like both esbuild and rollup can bundle things, but the way they handle like the module formats in JavaScript, like ESM, CJS, all that stuff, they just do it quite a little bit differently. So you'd run into these problems now and then, and it becomes these little paper cuts in the development experience that we really want to get rid of, right? And there's the pipeline inefficiency. So think about how the three things are written in different languages. So, but they all need to work on your source code. They all need to parse your source code. So actually the string is then first parsed from JavaScript to Go, parsed and transformed and serialized back into strings in Go, then sent back to JavaScript, then go through the same thing again in JavaScript, then send to Rust again for the same thing. So you can just imagine, like, if the system is built from scratch, this is madness. Like, you're just doing so much duplicated work just because these things are not designed to work together, right? And also, like, we started Vite as a no bundle dev server, but it has shown its limits when people start to use Vite for more and more ambitious use cases, right? When I started Vite, we're like, okay, we have a tiny app of 100 modules, it's blazing fast. But later on, people are like coming to us and say, hey, like we are using Vite in this like crazy enterprise application, and like we have 5,000 modules up front unbundled, and it's making the dev server really, really slow. So we're like, okay, like maybe unbundled dev actually has a bottleneck that we need to fix. So our first instinct is to unify the bundler, right? Replace all three of these things with just one solution that does all the things we need from them. And it's called Rowdown. It's a Rust bundler that we built from scratch. And it's a kind of a play on rollup. So we are going one level down to Rust. So we call it Rowdown. And as we are building Rowdown, we're like, wait, like Rowdown needs a parser. Rowdown needs transformers. Rowdown needs minifiers. It has all these lower level things we also need to sort of unify. So why don't we stop at the bundler? Why don't we go even deeper, all the way down, right? And then we realize, okay, like this sort of fragmentation, when we look at the parsers or transformers, it's also fragmented, right? So we're just looking at the whole problem all the way down the JavaScript ecosystem, the challenge it's facing. Like it's just like floating up all the way to the problem layer we are dealing with. But the problem actually goes all the way down, right? So we survey the whole ecosystem for the even lower level pieces, the foundational pieces, like the parser. There are like over 10 parsers for JavaScript. Like there is a website called astexplorer.net. If you work with JavaScript tooling, you'll probably know it. Like it has a drop down that like allows you to explore the AST differences of 10 different parsers in the JavaScript ecosystem. And just making them work together is just so much work, right? Transformer, there are like 5 competing solutions. Test runner, linter, formatter, bundlers, monorepo solutions. Every layer along the way, you're faced with multiple choices. Some of them, like you can see some of them appearing in multiple places, right? But none of them actually covers all of these all at once. So it's like, what do we do with this? Like, right? And the problems, like, it creates more materialistic problems in when you if you're like in a production environment, you're an actual engineer trying to build stuff, right? First of all, you're faced with so many choices. Like every time you start a stack, you're like, what do I use? There's outright incompatibility. Some tools are just like not meant to work together. Performance overhead, like I said, you're passing the same source code over multiple different parsers, serialized over and over again. Duplicated configuration, right? If you're using Webpack and Jest, you have to configure everything for Webpack first, then configure the same thing for Jest, but in a different configuration format. It's if you've done like web development in the past 5 years with Webpack plus Jest project, you definitely know what I'm talking about. So behavior inconsistency, right? These tiny little things that just like when you deal with like module interop, how do you resolve node modules? There are many small things that can go wrong. So overall, like in production environments, people actually spend more than you imagine on just like choosing, fixing, maintaining, upgrading the tools, right? So we want to change that. To eliminate all of these problems, we need a unified toolchain for JavaScript, just like Rust has Cargo. Why can't we have something like that for JavaScript, right? So this is pretty ambitious goal, right? It's not something. There was a company called Rome actually tried to do this in the past. They raised some money, and they essentially failed because they started writing everything in JavaScript. Then halfway through, they're like, "Wait, this is too slow. We need to rewrite it in Rust." So they spent another year rewriting everything with Rust, and then they ran out of money because there are some other issues within the company, not just the technical side of it. So people are thinking like, okay, like maybe this is just not meant to happen. JavaScript is just like going to be fragmented forever, right? But our conclusion is that okay, like it's fragmented, true, but there is a never seen before, unprecedented convergence happening in the ecosystem, and it's centered around Vite. Like we've never seen so many framework authors, library authors, and also developers all being so, enthusiastic and rallying around a single tool, and that's Vite, right? That's our leverage to actually make this happen. Okay, so and we also found people who are passionate in this space, people who worked on large-scale Rust tooling at companies like ByteDance. So I happened to meet them at a conference, and we're like talking about all this madness, and we're like, yeah, there got to be someone who just step up and try to fix this. And we're like, why can't that be us? Okay, so that's why we found the company Void Zero. So this is essentially where we're basically setting the company for the mission to build the unified toolchain for JavaScript, eliminate all these inefficiencies, and try to make web developers more productive than ever before. So the toolchain overview here on what we are actually building is at the bottom level, we have OXC, which is the lowest level language toolchain that includes parser, transformer, resolver, semantic analysis, linter, formatter, minifier. It's a lot of stuff, right? But you can see we have ticked a lot of boxes already. Minifier is almost done. On top of OXC, we're building Rowdown, which is the bundler that actually does all the things we need in the same single solution. And on top of that, these is going to essentially rustify Vite from inside out and make Vite more performant and more consistent. And Vite powers Vitest, so Vitest is going to benefit from that too. And Vite and Vitest is already supporting all these higher level frameworks, right? So all of them can benefit from all this foundational work all together. And we're going to also group all of these individual open source projects into a coherent package called Vite Plus that is essentially the cargo-like experience, but for JavaScript. So this is what we're doing. And you might be asking, why Rust, right? A lot of the lower level pieces are written in Rust. So for us, there are multiple aspects of considerations. First is Rust offers a good balance between the performance ceiling. You can get as close to Metal as possible, C++ level performance, but with memory safety, right? There are other languages like Go, which can also be performant, but is garbage collected. So there are areas where you just don't have control over when it decides to do the garbage collection, and you can have spikes of latency and stuff. And then there's languages like Zig, which is essentially a more modern C, which require you to manage the memory manually. So the correctness guarantee is not as strong as Rust. And also, the more important thing is Rust already has a very active ecosystem around JavaScript tooling. There are a lot of people enthusiastic about Rust. They're already building things in Rust for JavaScript. So it's easier to find relevant libraries and contributors. It has mature JS interop. There are solutions like NAPI-RS that's kind of already solved like how do you call Rust code from JavaScript, right? And there's mature WebAssembly support, which is kind of important for tools for web dev because you probably want something to also be able to run in the browser, so you can like debug and test it directly in the browser without having to like download it onto your own machine. So and also a note, we're not trying to Rustify everything. So we do believe there are like CLIs, APIs that like need constant tweaking and iteration. It's better kept in TypeScript because that allows us to move fast. But Rust is reserved for well-defined and perf-critical tasks, like how do you parse JavaScript? It's a very well-defined problem, so we want it to be as fast as possible. And it's not going to change like every year. Well, there are new features added every year, but you don't need to tweak the rewrite the parser every year, right? You just need small additions. Okay, so the progress so far is we've done a lot of these things, like I showed, and the performance is really what we care about. We are essentially the fastest solution in every category, and because the people working on these problems are expert Rust engineers, OXE actually is faster than some other Rust solution. Other like comparable solutions also written in Rust. So like they're both written in Rust, but there can also be 3 to 5 times of performance difference just based on how well you write it, right? So careful memory management, like say we use an arena allocator to put things, essentially put all the AST nodes in the same chunk of memory, and so that we can drop them all at once. So a lot of these little things add up to unparalleled performance. And there's less memory usage, smaller binary size. We're optimizing every category. So essentially, we have people who are just obsessed with optimizing stuff in Rust to work on these problems because we want to build the best possible foundation for an industry standard. So the Rodan is a bundler, right? So we essentially went from 0 to beta status in around about a year and a half. So now we're really close to getting Rodan into production. We're putting it into Vite integration right now. So we're essentially testing the integration by putting Rodan into Vite, then put that version of Vite into these downstream frameworks using Vite and run their test suites. This is what we call the ecosystem CI. So we are not only running Vite's own tests, we are running these significant dependencies that uses Vite and testing the compatibility with the existing ecosystem. So we're around like 80 to 85% there. So probably in a month or two, we'll have a beta version of Rodan Vite that is available for people to use. So the performance of Rodan is also significantly better than most of the other compiled to native bundlers. We're not even including JS-based bundlers in this case because those, if we put them there, the bar would just go out of the screen. Or they would run out of memory. And another aspect, like I said, Rust WebAssembly support is really, really good compared to Go. So ESBuild is written in Go. Its native binary is extremely fast, but its WebAssembly is abysmal. Like, because Go's WebAssembly support is just not great. So Rodon's WebAssembly running in the browser is still the fastest possible you can get. And this is actually quite important because I don't know how many of you are using those like AI gen tools nowadays, like Boat or Lovable. Um, those tools that allows you to like spin up a web app instantly just by prompting in the browser, right? A lot of them are using Vite under the hood, and they can do that because Vite is fast enough to just like be installed on demand in the browser and just run in the browser. So what's next? We're essentially, like I said, rustifying Vite from inside out, replacing these internals with our unified solution underneath, and putting more and more well-defined problems into the Rust scope while keeping Vite itself API compatible with the existing usage. And on top of that, Vite Plus, which is our cargo for JavaScript, that's going to cover today's Vite only does dev and build. But we have vtest that can do test and bench. We have voxc that does linked and format. We have vpress, which covers documentation. Right now it's coupled to Vue, but we're making it framework agnostic. And then you can leverage Vite's transform pipeline, resolve pipeline to run TypeScript directly in Node.js. So kind of give you a bun-like experience without having to leave Node.js in a sense. And then project scaffolding, how do you scaffold a new project without thinking too much about it and make sure it's scalable for the long run. And if you are you go into big companies, big enterprise, they're doing mono repos, we also have solutions for that as well. So we want to essentially put all of these in a very coherent package. So this is going to be free for individual use. There will be special licenses for enterprise use cases, but our ethos is to keep things free and open source if you are students, individuals, even small businesses. But we try to make the profitable big companies pay their fair share for open source. Yeah. So yeah, that's it. Thank you.